this like in the last.
Yeah, this isn't cool.
And also they're online.
I miss being able to see.
Doesn't really affect your water drinking.
What's
Kind of
that?
lame.
What is it?
Bottle.
Oh. Oh.
I
I don't know. Okay. Good morning. Good afternoon.
Guten Tag.
I was gonna, and then I wasn't feeling it. I don't know why. I wasn't feeling it today.
Guten Tag, which of course is German for Guten Tag.
No, good Tag. The joke is I translate Guten, but not Tag. I find that funny.
Is Todd this morning?
Really? That's
Tag
the
is
joke?
day. Morgen is morning. So Guten Morgen, Guten Tag, and Guten Nacht. But just like we do, like another one of these intricate things of English, where if you say good night to somebody, you're saying goodbye. But if you say good evening to somebody, you're saying hello. Isn't that weird? English. All these little... That's right. So to everyone who isn't watching online, this is our discussion about... I think about these things a lot. Like, for example, my wife has a friend whose kids' first language is French, right? Like they speak French and English, they're bilingual, but they speak French. And they're little, just wee little guys. And so one on the weekend was like, I have cold. And of course to us that sounds weird because we say I am cold. But the French say I am cold too, but they mean something different. If you're French and you say I am cold, you mean that you are... Sorry? No, it means that you're a cold, uncaring person. I'm cold. I'm unfeeling. I don't care how you feel. And I have cold means that, my body is cold. So they differentiate these things. And we do that too, but we just use the same word. That person's really cold. What do they mean? Are they shivering or do they not care about you? Maybe both. Anyway, okay.
I'm shivering and I hate you still.
Anyway, okay, I'm just going to get the link to this because I wanted to send it to Jerusha because she mentioned she was going to be away today.
Is there any, reason there's just the spoon permanently on the desk?
None in particular. Probably that's just the spoon I usually use to stir my coffee and it sat there. Yes. Oh, okay. Okay. Oh, here we are. Oh, look at that.
How many dislikes you get on your videos?
Oh, look at that guy.
Can we see
That's
how many
nice though now.
dislikes you get on your videos?
No.
Why not?
Oh.
Didn't you mention that you used to like looking at so many people disliked your streams?
Yeah.
Mr. Orlando, guess where this is made?
China.
China.
There we go. Okay.
For Caleb.
Welland? I don't know. Okay, let's get to work. So.
I don't know.
Okay. Can we perhaps get this front light turned off? Make this a little... That's better. Okay, so. Today we're going to talk about stoichiometry again. And remember, when we talk about stoichiometry, we're just talking about recipes. We're just talking about the fact that if it takes 2 slices of bread plus 3 strips of bacon plus, what do you think, two tomato slices?
4.
4, oh, okay, yeah, we like lots of tomato.
And then 2 left.
If that's, and of course you need some mayo.
Yeah. Maybe throw a little egg in there.
Okay, so if that's our recipe, if that yields 1 BLT sandwich, right? There we go. That's an equation. That's, exactly.
BLT sandwich?
Sure, 2 slices of bread, 3 strips of bacon, 4 slices of tomato, 2 pieces of lettuce, 80 mils of mayo, 1 BLT.
Oh, 4 slices of tomato. Okay.
You said 4. I don't know, that's a lot.
Yeah,
Are we thinking 2?
Yeah.
Yeah, I think 2 is a more reasonable number. And 80 mils of mayo is probably quite a lot of mayo. Let's say 8 mils of mayo. Yeah, we don't want to. You don't want to be drinking your BLT. Okay, so there we go. So,
Put it in a blender.
so if that's the recipe, remember that stoichiometry is just saying, okay, what if instead of having 2 slices of bread, what if I wanted to use 24 slices of bread? I'm looking to do that whole thing. What did I do there? I timed it by 12. So how much bacon would I need? If I was going to use up all 24 slices of bread, I'm going to need?
36.
Very good. 36 strips of bacon. How many slices of tomato am I going to need? 24. How many pieces of lettuce am I going to need? 24 is correct. How many mils of mayo am I going to need?
96, I believe.
Yeah. Very good. And how many BLTs will I make?
Too many.
Just enough for me to be hungry. Still. After eating all. Can we make BLTs?
I think that's exactly what you said. How many? 12 is correct.
Why
Good.
are you erasing it?
Because it's not the answer I want, Preston.
That is the answer you want.
Okay, so 12. Good. Right? So,
Is that going to be on the stream?
oh yeah. It's on that. Oh, my stream's a real LARF riot. All right,
How
great.
many times I popped up on that stream?
Oh, a pox upon you. So,
178. I don't know. I'm just guessing.
So, that is stoichiometry at its most basic. It's just scaling up and scaling down recipes. That's it. That's all we're doing. And it's just the game of saying, if I have 36 strips of bacon, how many mils of mayo do I get? Or, if I'm making 12 BLTs, how many pieces of lettuce do I need? That's all stoichiometry is. Yes, it's all ratios. What a wonderful thing to say. That's exactly right. Yes?
Before you start writing, can you move over a bit?
Ah, I would love to. How is that?
Thank you.
Wonderful. Is that good for you too?
No.
I'm in the way. Okay. How's that?
There we go.
Oh, good. Well, I live to serve, team. Okay. So we're going to start with a reaction. All right? And we're going to start with a reaction between iron 2 oxide and sodium metal. Okay, we can go ahead and turn that down. Thanks. These guys have to listen to me once as it is. Let's not make them listen to me twice.
Wait, can they hear us too?
Yes.
Hey, Preston.
Wait, they can hear. Wait, they can.
Nobody likes you. Then, Preston, I have a little secret in there for you. You're going to have to re-listen to hear it. All right.
What's your YouTube name?
So let's take a look. I'm going to get fired. Okay, let's take a look. Okay, can you actually turn that down?
If you don't want to get fired, don't say I'm going to get fired on your YouTube
So,
stream.
I want to react sodium metal with iron 2 oxide. Can we do that? Oh, good. That's great.
I should do that when I get home.
So, sodium metal. Now, what is this lesson is brought to you by Skillshare. Now, iron 2 oxide. Iron 2 oxide. How's that going to work? What is iron 2 oxide? What's symbol for iron? Fe. If it's iron 2, what charge is it taking? Very good. And oxygen always takes? Negative 2. So what's the formula of iron 2 oxide?
Hey, everyone likes.
You found it. Good.
You said Preston, no one likes you.
Oh, he said Preston. I didn't hear that part. I just heard nobody likes you.
All right, I'm getting fired. Anyway,
Yeah, you're getting fired.
okay.
That's what I'm going to get
So
fired.
iron 2 oxide has a formula of FeO. What state of matter is that sodium?
I feel like I'm at slime throwing me off.
It's a solid. Good. What state of matter is the iron oxide? It tells us that it is a solution, so it's got to be aqueous. Good. All right. So first things first, I want to balance chemical equation. You can do that.
Thanks, 10 minutes.
Sorry?
Sorry. I saw it said exactly 10 minutes on the live stream.
Oh.
10.
Last year I got to have that wonderful moment when my car was 222,222 kilometers on the odometer. It was very cathartic. I did. It felt nice. I was like, that's a good moment. I'm going to remember that one on my deathbed.
No, you won't.
I need like
Once you
just
get
show the
Alzheimer's, you
photo.
probably will.
That's instead of your face on your casket, it's a photo of your speedometer.
I'll say to my kids as they gather around, I want you to know I was so proud of my Chevy Volt when at 222,222 kilometers.
Disappointed me.
Not like my Chevy Volt when it went
You were able
222,000.
to get the picture of that. Sorry.
I'm going to put that in my pocket in my casket.
Driving.
All right, I want this equation. Come on, let's talk more rock.
Does she know what Cybertruck payment yet, though? Oh, no.
No, it's such a depressed no.
I'm biding my time. I'll pick my moment.
Your moment is Christmas Day.
But wrap it for myself. I should give it to her as a gift.
No.
Be like, I got you this. It's a bad idea. It
don't
also
From
violates
your
my
own
spending.
money.
I don't think anyone would want to drive that anywhere or be seen.
I don't like NAO. I don't like NAO.
What?
Because what charge does sodium take?
Oh, there's no.
Yeah. Okay, so obviously what's going to be by itself on this side? If this is a Fe, which is iron, iron's going to be on its own.
Sodium is 1, right?
That's right. Sodium takes a charge of 1. Oxygen takes a charge of 2. So the formula of this guy will be
Very complicated.
very good. And sodium's, anything with sodium dissolves basically, so we can assume that'll be aqueous. All right. Very good. Anything else to balance it? I don't think so. Yeah. Blaine told me that. But other than that, do we need anything else? No, I think we're good. Okay, nice. So we have a balanced chemical equation. You can't do stoichiometry without a balanced chemical equation because stoichiometry is all about using the balanced chemical equation. So you need a balanced equation to do stoichiometry. That is a requirement. Now, the question is, let's talk about the question. In this question, we're putting in lots of sodium, all the sodium we could need. So that's good. We're going to have excess sodium, which means we don't have to risk running out. But how much solution are we using?
2 moles sodium.
Well, that's true in the reaction. In the actual physical reaction I'm doing in the room, yeah, this is what I've got. In other words, I want to imagine this. I have a beaker, and in my beaker, I have iron 2 oxide solution. I don't know. I didn't think that far ahead. We're going to pretend for the sake of this question that it is. It actually, it might just be a suspension in there, but we're going to pretend it's a solution. So there we go. And how much of this do I have? I have 100 mils. And what's the concentration of it?
0.5 m.
Okay, does that make sense? That's what I know. And it never hurts to write my given out. I know that my volume is 100 milliliters. Yeah, and I'm not changing my volume here, I don't think. Yeah, for sure. Oh, take it easy. I hope you get feeling better. If you need help with this tomorrow, just let me know. And our concentration of FeO is 0.50 molar. Okay. Now,
What does it sound?
I don't know.
Just talking?
I think talking in a different room or simply playing back the stream but very quietly.
Could be that. And the question is, how many grams of iron? Our goal is to go from this information to grams of iron. Oh, I think I know what it is. Will you keep it down in here? Put it down a couple pegs. Sounds like a kettle.
It's like kettle
Who's in there?
No, I often like think of me sitting in the back of the room watching. Anyway, that's the end of my story. All right, I figured out the source of our sound. Who's in there? Never mind. Let's just say the person who's in there took a biology class with me once, and every time I looked at the back of the class, they were just watching Dr. Phil. Anyway, I watched a lot of Dr. Phil in that class. Okay, so as always, I like to kind of think of my roadmap. It just helps me. What is the central unit in chemistry? The thing we always want to know. Yeah, how many moles? And N stands for number of moles. You don't even have to worry about that. The mole is the central unit. If you know how many moles you have, what are some of the other things you can figure out?
Other moles.
Yeah, we can figure out how many moles of something else, which is super useful. So we can say the moles of B, if this is A. Awesome. Now, from either of those, what can you learn? Yeah, if you know how many moles of one thing you have, you can know how many grams of that thing you have. Ooh, good, yeah, for sure.
And then volume.
Very good. Before we get to that, to go from moles to grams, what do I need? Where would I look? Periodic table. Good. If I know how many moles, what else can I have? Preston gave me one of them. He said that I could know the concentration. And all I would need to, and by the way, what do we measure concentration in? Yeah, specifically? Moles per liter, which we sometimes write as big M, right? Molar? Awesome. What do I need to know if I'm going to go from moles to concentration? I need to know the volume. And I could do the other trick. I could actually do the opposite, where I could actually figure out my volume.
Oh, I think you put MA twice.
Oh, I should have put B.
Yeah, C.
There we go. Sorry about that.
And you did MA twice too.
Which is the one originally called you out on, but you fixed the other one.
Yes.
B.
All right, and we could figure out the volume of B, right? So like that's a B, believe it or not. So that's kind of a roadmap. By the way, if I'm going to go from moles to volume, what do I need to know?
Believe it or not.
If I'm going to go from moles to volume, I'll need to know the concentration. Good. So that's kind of our roadmap. You kind of think of it as the gear shift of all this. So if I'm trying to go from this information with volume or concentration, the nice thing is I can start either place, right? I know the concentration of this thing. I can use that to figure out how many moles of this thing I have, which I can then use to figure out how many moles of something else I have, which we can then turn into a gram. Does that make sense? Or I also have the information of the volume. I could start here and go there and go there and then go there. Either one works, but I have a rule, which is I look at the answer. Is this answer a fraction or not a fraction? And my advice is if you're ending with not a fraction, you should start with not a fraction. Which of these pieces of information is not a fraction? 100 mils is not a fraction. So I'm going to start with that. Again, that's not a hard and fast rule. You could absolutely start with the concentration and get there. You just have to be more careful. And I don't like being careful. So it's easier if you start with the not a fraction. So I'm going to start with volume. From volume, we're going to find, yeah, and that volume is the volume of iron oxide solution. So I'm going to find moles of iron oxide solution. But from there, I can figure out moles of anything I want. And since the question asks about iron, I'll figure out how many moles of iron I'll get. And then once I know how many moles of iron I get, it is easy to figure out how many grams of iron I get. That is our roadmap.
Mole.
Is that reasonable? Volume to moles to mass. So I like to kind of write that out. I'm going to go the volume of the iron oxide solution. We're going to turn that into moles of iron oxide. We're going to turn that into moles of iron produced, and we're going to use that information to know how many grams of iron will be produced. That is kind of my roadmap for this question. I like to map out what I'm going to do. Questions about that? Do you want to do this one together, or do you want to try it? We'll do it together. All right, so we're going to start with the volume. Now, if you want to jump right into liters, you could convert this to liters in your head. I'm just going to write down as 100 mils of solution. And then the first thing I'm going to say is, I don't want to talk about milliliters. I need to immediately talk about liters. Okay, and that's an easy one. How many mils in a liter? 1,000. Okay. If you want to just do that in your head and just say this is 0.1 liters, I don't fault you for that. That makes a lot of sense. But I'm going to do the step in dimensional analysis. So it's dealt with. And I'm going to remove that word solution because I don't care. Obviously, we're talking about the solution. There's only one liquid in this whole question. So there we go. Okay. Now, if I stopped calculating now, I'd know how many liters my solution is. I don't care about that. If we look at my actual steps, I'm going from volume to moles, which means I don't want to talk about liters. Where should I put it? I do want to talk about moles of FeO. Do I know how many moles of FeO are in a liter of my solution? As a matter of fact, I do. I know that 1 liter of this stuff contains... Good. Where should I put those numbers?
0.5 on top, 1 on
Very good.
Is it 1 liter though?
But it's per 1 liter.
Right.
Concentration is always moles in 1 liter. Doesn't mean you have a liter. You could have half a liter. You could have 50 liters. You could have 6 billion liters. You could have an ocean. But concentration is expressed in moles in 1 liter. Okay. If I were to stop calculating now, liters cancels with liters, what would I know? Moles specifically of? Yeah, I'd know how many moles of iron oxide were used in this reaction. But I don't want to know how many moles of iron oxide were used. I want to know what? Yeah, and can I go from moles of iron oxide to grams of iron directly? We have to do our stoichiometry, right? I can go from volume of iron oxide to moles of iron oxide. From there, I have to go to moles of iron. Good. So, how do I do that? Help me set this fraction up. Moles of iron on the top and on the bottom. Very good. Moles of iron oxide. And this is a nice, easy stoichiometry. What are both of those numbers? 1 to 1. All right, that's a nice, easy ratio. But we don't really care if it's easy or hard. It's the same work for us. If I were to stop calculating now, what would I know? I'd know how many moles of iron will be produced. But of course, the last step is we want to go from moles of iron to grams of iron. Good. How am I going to do that? What do I put on this fraction? Very good. And 1 mole, is this 55.845?
845.
Nice. And moles of iron will cancel with moles of iron. And when I've finished this calculation, what am I going to know?
Mole, gram of iron. Grabs my calculator.
Yeah, I could. Oh, for the love. You're welcome. And just looking at it, we're talking 0.1 times 0.5, so 0.05. Oh gosh. So we should be talking like 2.5 grams ish. It's gonna be a little less than that, or a little more than that, because it's 55.845. So we should be talking pushing 3, 2.8, 2.79. Okay, that's not bad. we're talking 2.79 grams.
Well, we
Are
got
liters and milliliters
digits for moles of FeO.
Yeah, well, and in fact, I got to be careful here because really the way I wrote the question, how many sig figs do I actually have? 1, but we're going to pretend that was 50. If you notice, every time I wrote the question, I wrote it as 50, just because I don't want to work with 1 sig fig. That was stupid of me.
But you have 100 milliliters, so it's not 1 sig fig.
And we'll assume that that is 1.0 times 10 to the 2. There we go. Yeah, I want to be in 2 sig fig land. So what do we say, 2.8 when it rounds? And 2.8 grams of iron. Therefore,
So do liters count as infinite sig figs?
here it does, because we're saying that's moles per 1 liter exactly. And these are infinite because the definition of a milliliter is 1,000 milliliters is exactly 1 liter.
And
So
those moles are also infinite.
that's right. So the only thing here that's measured is that is a measured value, that's a measured value, and that's a measured value. And again, that should be 1 sig fig, just as written, but we're going to assume what they actually mean is 1.0 times 10 to the 2, which would be 2 sig figs. That was sloppy question writing by your sloppy teacher, who feels sloppily guilty about it. Sorry? Oh, good. Yeah. And that's a great question. Will this reaction actually happen? Would sodium be able to displace iron?
I think so. Iron's relatively low on that.
Very good. And sodium is very reactive. Very good. All right.
But is there such thing as aqueous iron oxide?
That's a little more sketchy. We're going to pretend that it dissolves beautifully. Could still react, for the record. Just because it wasn't aqueous doesn't mean they wouldn't react. It just means that they wouldn't react
How they reacted?
how I wrote they reacted here. All right. I want you to try this one. And I want you to try it with a minimum of input from me. Talk to each other. Do your best. We'll take it up together. I'm not going to leave you in the lurch. You know that. Excuse me. But I want you to make an effort to do it by yourself, okay? I'm going to give you, maybe 6, 7, maybe even 8 unsupervised minutes just to try it out. Again, do your best effort. Worst case scenario, you get it completely wrong and we just fix it. That's not a big deal. That's a great worst case scenario because that's a perfectly fine outcome. Do your best.
You said excess.
You said Fe.
Oh, for goodness sakes. Now let's all assume that we will get copper 2 sulfate, and that will make our lives or iron 2 sulfate rather, and that'll make our lives nice and easy. All right? Because the possibilities would be iron 2 and iron 3. We're going to use iron 2. Sorry about that. I should have specified.
You can ask 1 6 iron liters again.
Yeah, treat it like 3. Let's assume we're using, you can even treat it like 3. Let's assume we're using good quality volumetric glassware, okay? How we doing, team?
There's a lot here.
There's a lot going on, for sure. This is tricky. We are getting to some sophisticated stuff.
I thought we were supposed to do it for you, Cam.
4U Chem is way more sophisticated. It's also wonderful. It's a course I love. I love teaching it.
Then teach it.
I do. I think next year? I'm not this year, right? Or
This year.
It is.
this year's the chem, next year's the bio.
No, you have chem and bio this year.
But not the 4U bio. I have the 3U bio this year and 4U chem. Yeah.
I know. For you Chem is this year because I'm in it.
Excellent.
Also, are you teaching for you Chem?
Yeah.
Better be.
Yeah, the only 4U chem teacher in the building right now.
Oh.
That's great. I'll just put those charges out there. You good? The only thing, like, this is perfect. Don't make your life harder than it needs to be. If that's 2 and that's 2, that's not wrong, but they can just both be 1s. And then you don't need the brackets for the 2s, right? And same thing over here. So, like, you're not wrong, but there's no point in saying, like, we don't call it Na2Cl2 because NaCl is just easier, right? Does that make sense? Other than that, you're good. We'll make sure people are on the right track to begin with. Let's talk balanced equation. We are reacting copper sulfate solution with iron. So iron's easy. I got it. I don't know, because I want to. Would you like me to do it the other way?
Does it matter?
No, it makes no difference.
No, it
2 plus 3, 3 plus 2, same thing.
Please don't.
But you want that like that?
Yes.
Cool, okay. No. And then copper 2 sulfate, what charge does copper take in this case? What's the formula for sulfate?
SO4.
What's its charge?
Negative.
Awesome, so what's the formula here?
Please don't. No.
CuSO4.
Very good. CuSO4, and it's dissolved in water, so how would I indicate that? Aqueous.
They can explode your lab.
They might explode my lab. Okay, when this reaction happens, what will be by itself on the other side? Sorry? Yeah, Cu now lives all on its lonesome. And what will the compound be? Well, iron we said to use which one? 2 plus? And SO4 we said has a charge of 2 minus. So what will the formula be? FeSO4. Very good. And that will be aqueous, if I'm not mistaken. I might be mistaken. Okay, there's our reaction. Now, what do we know? We know that we want to know the concentration of this. That is our question, right? Do we know a volume? Yeah, and again, I'm just going to make life easy. We're going to say that's 1.0. I'm sorry. Is there anything else we know? Yeah, mass of which one? The copper that's going to be produced. And how much copper are we going to produce? 1.2 grams. Very good. So we've got two given values to work with. We have a volume and we have a mass. Okay, that's fine. What are we trying to find? We're trying to find a... Now we'll note that that is a fraction. Well, we said if I'm finding a fraction, I should start with a fraction. Uh-oh, none of my givens are fractions. Make one. And that's actually good because when we do concentration, what do we put on the top? We put stuff and we put liquid on the bottom. Can we do that with the givens we have? Great. So what should I put in here? 1.2 grams. And grams of what? Of copper. And on the bottom? Very good. Now here's the good news. That bottom is all ready for our fraction. Does that make sense? We have already taken care of the bottom half of our fraction. Because in the end, what do we want our answer to be? Moles per liter. Hey, we have already taken care of per liter. Now we just have to get moles. And specifically, we want moles of what? No, eventually we want moles of copper sulfate. So let's take a look here. We're going to have to go, Yar, not playing nice. We're going to have to put a mass into moles, right? And then we're going to have to put a volume here, right? Well, sorry, we know this volume here, so that's okay. I mean, we also know that volume, but I don't want moles of copper per liter. I want moles of copper sulfate. So we'll go here, and we can use the volume to go across. So we're going to have to turn that grams into moles of copper. Moles of, copper. Then that moles of copper, we're going to have to turn into moles of copper sulfate, and then we can turn that into a concentration, which we've already done the turning it into a concentration bit. Does that make sense? We've already divided by liters, which is great. That's actually the first thing we did. So this up here, we're going to start with grams of copper. We'll turn that into moles of copper. Then we'll turn that into moles of copper sulfate. And then down here, we're going to plug in liters, and then we'll be done with it. Does that make sense? That's our roadmap. So I want to get rid of grams of copper on the top. What should I do? Grams of copper on the bottom. What am I going to put on top? Moles of copper. That's nice. I can do that easily. Where would I look for that particular piece of information? Periodic table. And for some reason, I'm blanking on it. I can't remember it.
63.5.
Ooh, that's good. That's not what I was going to say. Five, 4. Okay, so I'm going to do 5.5. Because we're in 2 sig fig land, so I don't need to go crazy here. What cancels? If I stopped calculating now, what would I know? Per. Yeah, I'd know the concentration of copper, but that's not the question. So what do I need to do next? Very good. And that will give me what I want. How do I get rid of what I don't want? Put what on the bottom? Very good. And from the equation, what will make this fraction true? It's a 1-to-1 ratio. Very good. And if I'm not mistaken, that will now give us what we want. Moles of copper sulfate per liter, right? Great, so let's just calculate that. On the face of it, 1.2 divided by 63, this is going to be low. It's going to be on the order of like 0.02 molar. 0.0188, so 0.019.
Oh, you were so close.
9.
Well, that was the best I could do. Okay, and how would be a better way to write that, of course? How would I say mathematically, like, the concentration of copper sulfate is 0.019 moles per liter in, like, nice, short, easy, symbolic.
Hard bracket.
Hard bracket.
CuSO4.
Very good.
Hard bracket.
Yep.
Equals
Yep.
0.019. No. All right.
Okay, we're good. Yeah, that's good. That's right. That's right for the test.
Yeah, that's how you write it.
I'm gonna write that on a test, and I better get full
Very
marks
solid
for it.
with it. What does that say?
No, you know what I mean. I'm going to write that on the test.
And I know how much you love when I switch to all caps. There you go. Of course, what I really need to put is
M.
big M, yeah. Big M. Big old M. Mega M. M mega, not M micron. Do you guys know that? With the, because the current variant of COVID is called the Omicron variant, right? But Greek lesson, Greek doesn't have one letter O, it has 2 letter O's. And not just like we have an uppercase and a lowercase. Within that, they have a small o, and they call that O. What would we call like a small USB port is a
Micro.
Yeah, so Omicron, small micron, and they have a big O, and we would say that is
Big cron.
omega. Omicron is the small o, omega is the big O. That's what's the lowercase omega? Can we?
Is it literally just a smaller omega?
You'd think, right? But no. Let's look it up. That's the lowercase omega. That's right. That's an uppercase omega. Oh, I gotta press Alt equals. No, again, not lowercase. Not lowercase. It's a different letter, but it's.
I had no idea Omicron was the small omega.
Yeah. So those are omegas. That is lowercase omega. This is uppercase omega. And then
Are they used interchangeably?
Omicron. Oh, I gotta press Alt equals again. Hello? Hello? I did. Oh, does it not? Am I spelling it wrong?
You just did.
How do you spell Omicron?
OMICRON.
Yeah, that's what I was putting in. Isn't that interesting? So Omicron, theirs literally just look like O's. Like very similar. So that's uppercase and lowercase Omicron, which we use as our O. And then you can see their omega is where? Down there. That's uppercase and lower omega. These are the letters of the Greek alphabet. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, z, omicron, pi, rho, sigma, tau, upsilon, phi, chi, psi, and omega. Not to be confused with epsilon. Epsilon and upsilon. Anyway, there you go.
We're almost in the 5-year range of COVID.
Nate Silver, who's a statistician, like right at the beginning of COVID, said, "Can't wait till we're all on Twitter complaining about the Omicron variant." And then, a couple of years later, we're all on Twitter complaining about the Omicron variant, and it all felt a little too real. Oh, it's true. Okay, so there we go. That's a job well done. Now, there's only one thing we can do to make this worse.
That.
Remember limiting reagent? Well, don't stress. Don't stress, because remember if we came back here, what if I had 8 slices of bread,
That's why I did. That's why I said 4.
100 strips of bacon,
That's why I said 4 slices of tomato.
42 slices of tomato, 6 pieces of lettuce, and a whole friggin' bucket of mayo. How many sandwiches could I make?
How big is your bucket?
Like it's big. It's big. A whole big friggin' bucket.
Lettuces per.
No, I'm not answering that. Look at the...
Oh, we're gonna use that as it.
This is the equation. This is the equation. That's 6 limits. And if that's 6 limits, how many BLTs can I make? Because if we look, this is enough to make how many sandwiches? This gives us 3 BLTs. This would be enough to give us how many BLTs? Nope, close.
Stuff. A lot. Enough.
21, good. This would be enough to give us 33 1/3 BLTs. This would be enough to give us 4 BLTs. And this would be enough to give us friggin' lots of BLTs. And so which of these limits? That limits. And so we get 3 BLTs. All right? That's the basis. If you can figure out how many BLTs you get, you can do limiting reagent. Does that make sense? So I want you to take a crack at it, take a stab at it, give it a try, do your best. Try this out. We'll make the equation together. We're putting aluminum. What's symbol for aluminum? Aluminum with copper chloride. Copper chloride. What charge does copper take?
2 or 3.
In this case? And chlorine always takes? Nope. Very good. So what's the formula of this? CuCl2. And when this reaction happens, what are we going to get?
Stuff.
And things.
Water.
Cu will be by itself. What charge does aluminum take?
+2 3 positive.
Great. What charge does... What will it end up with? Okay. So Cl always takes... Great. What's the formula that's going to be? Very good. Are we balanced? Ooh, and this one kind of sucks to balance. Not that's a big deal, but it's not like my favorite thing to balance. What's it going to be? Yeah.
No.
Yeah, I think that's right. Keep going.
Why would you go to the highest point though? You go with 2 for
3 Cu.
3 of these. And how many of these?
2.
And then?
2 IF.
Yeah, and that's not the order you had to do that in, obviously, but that'll get you there. Nice. So now let's talk given. What do we know? Do we know the volume of this whole thing? What's the volume?
Oh.
You're gonna get copyright strikes.
Oh, I am going to get copyright strikes. There we go. I'm going to claim fair use. That was an educational ringtone. Okay.
No, this
No,
is
how
stupid
far?
Instagram thing.
Stupid Instagram. Okay, talk to me. What else do we know? What is our given here? Yeah, we know that we have 2.4 grams of this. And what else?
250 milliliters
We know we're in a 250 ml solution. Yep.
and 5 mol, 0.5 mol.
Yeah, we know that the concentration of this is equal to 0.5 molar. Right? Lots to sort through here.
I don't think you balanced that right.
I think I did. 2 aluminums, 3 coppers, 6 chlorines, 6 chlorines. No, you have 4 chlorines and 3 chlorines. Right? On the left you have 4 chlorines, and on the right you have 3.
Oh, that should be accurate.
Okay. Now, you're going to have to answer it twice using both of your givens. You're going to have to answer it once using that given and once using that given. What order you do that in? Entirely up to you. All right? Give it a try. Take a few minutes. Do your best. This one actually isn't too bad. You can do it. I have faith in you.
Who's under this?
I'm sorry, did you say Monday?
Her or him? Wow,
That's all stuff. He's
he's a trash. He's a guy. Ooh. I love it when people post about that and they don't know that it's a trap and they just kick her.
teacher here. He's in the back. Back? Okay. Elizabeth Brody here. Elizabeth? Yeah, can I talk to you for 2 seconds outside?
What's up, Elizabeth Brody?
Oh, sure.
Is that what you called me? Oh.
That's not going away anytime soon. It's Mr. Orlando. It's now Elizabeth Brody.
Stop.
Her Mr. Luciani, not Luciani.
Luciani. Oh, I'm telling you, you said so.
Is it Matola?
It is.
Mr. Matola. I play with this kid on travel team.
Sorry?
I play with this kid,
Oh, do you really?
Lucas Matola.
Are BJ's computers available 4th period?
Sure. I've not been able to do that.
Do you know where they are?
There's a lot more aggressive.
Yeah, they're right in my room now.
Oh.
Right there.
Oh, okay. I thought somebody had them for the surveys. Problem. That's
They
like,
did in the morning, so I
Okay.
still got to sort through them.
That's
So that
fine.
part's a bit of a mess, but use it. That's fine. I'm cleaning up at the end of the day.
Oh, and I always, I'll put it back proper. So it's in this little room.
Yep, yep.
Is there a shirt there? I might as well grab while I'm here.
Failed.
Yep.
Did I fail or did I succeed?
You almost hit yourself.
I said it was a success.
Sorry?
I'm so sorry.
Well, we are trying to find a concentration.
Oh, Elizabeth Brody.
Concentration.
Yeah. How was it,
So,
Elizabeth
yes.
Brody? Brody, Mrs. Brody, how was it?
Do you see a red volleyball shirt in there? That's what I need. Check it. Okay.
It's in there, right?
Yeah, they just.
Oh,
I
okay.
I bought it. I just think it's
Nice.
not here.
Thank you.
No problem.
Brody, can you help me figure this out?
I get bullied all the time. Of course you do.
Why would we do the survey?
I feel like we should bring bullying back.
The grade 9 kids. The grade 9 kids.
Such good quality streaming, eh?
Being bullied back in grade 9.
Can I tell? Listen,
Too many weird kids. We should bring
They're
bullying.
really weird.
Listen, can I say something? This group of grade 9s is delightful and lovely. You just be nice to them.
They're not delightful and lovely. One of them bumped into me and then said, "Sorry, love," like I'm a child. And then a second time, I think it was the same
Hold on,
person.
Preston. You just told a story where somebody bumped into you and then
said,
tried to
"Sorry,
be
love."
very polite and apologize,
And
and
said,
you're like,
"Sorry, love."
"Oh, what a
Sorry,
loser."
love. And then the same one said, "Sorry, kiddo." A grade 9 called me kiddo and love.
That's awesome.
Kiddo and love. I don't know, but I know their
You
name.
need to calm down. You're blowing something that doesn't matter out of proportion.
I am not.
No, that's awesome.
That's what I've had so many grade 9s run into in the hall and start.
I'm just gonna start body checking grade 9.
They're so asses.
That's
I was serving once, and a guy called me. What do you call me?
kid.
He called me buddy, and I said, "No problem,
buddy.
Orlando, isn't this such great content for your stream?
Like all the way down the hall.
What? What? I'm gonna have a secret admirer on the channel.
Have I ever told you about my goodbye thing at the South Lincoln end of the year?
Yeah, was it like a massive slideshow?
Yeah. So, well, it wasn't a slideshow, but it was
A presentation.
I had these lovely kids who I really, really adored. And they were like, they got like the full Chris Float treatment where these poor guys at South, for whatever reason, nobody wanted to teach senior chem, nobody wanted to teach senior bio, nobody wanted to teach calculus and vectors, nobody wanted to teach advanced functions. So I had a semester where I had advanced functions, for you chem, please name that.
Please.
For you chem and for you bio. And then it was an MSIP school. So I had 8 kids who had me 4 periods a day. Think about that for a minute. 4 periods a day of Orlando. First period, second period, third period, fourth period. That's too much. But we had a lot of fun. It was a good time. But that year,
Maybe 3 times.
I got pink slipped. I got declared redundant, so I lost my job. And so they,
slipped?
I wonder why.
For what?
just redundancy. Just when
You're teaching 4
like
classes that
the number of teachers on the board is determined by how many students are on the board. So a few years ago, it was declining every year. So every year, teachers are getting fired. So I got fired like 5 times. But that's fine. You get hired back. But so they're doing the goodbye thing. And so these guys, at the end of the year assembly, and like my principal's there, the vice principal, the superintendent was there, I think the mayor of Smithville was there, and they said, now we're gonna, or West Lincoln, I guess, and now they said, now we're gonna say goodbye to one of our teachers, Mr. Orlando, and it's Kyle McGowan, who's this kid I really love. He got up there, and he said, Mr. Orlando, we made a little video for you. And like here, I streamed every lesson, and it started with a picture of my face, and then you just heard coming out of the speaker, Kyle, I hope your dog runs away. And it turns out he had just put together a supercut of me saying awful things to the class. And so, yeah, it was also like 3 minutes of like, when I die and go to hell, I'll be a grade 9 teacher. Like just things like that. And then he ended it, and this is true, I wish I must still have it somewhere, I gotta find it. He put together, with a beat behind it, my voice doing like, all the single ladies, put your hands up, and so on and so forth. It was pretty funny, but also a little embarrassing.
Hey, at least you were already fired, so I guess you can't get fired
Yeah,
again.
except I was in the process of trying to get, another job by applying. Yeah, those
Didn't you say the mayor was there?
Yeah, whatever. He lost the next election. Not my problem.
Oh!
Take that. What was his name?
Serve it
Joyner?
to him.
Take that, Joyner. And he was replaced by an idiot. Anyway, that's a different discussion. He was a really nice.
I have enough material to make
He was a really nice guy. And the current mayor of West Lincoln, not to get political, but that guy sucks. Anyway, we'll move on. Oh, he's like a bigot. He's like small-minded. He's counterproductive.
Let's not get demonetized here.
Allegedly, all of these things are alleged. I have heard.
There are no accusations.
I have heard these things said. I have no first-hand information, and I can neither validate them nor fail to validate them. The opinions expressed here are solely my own, and today's lesson is brought to you by Squarespace. Turn your dream into a reality with a beautiful website,
And
Squarespace.
start.
Okay, let's go. So let's deal with this 2.4 grams first.
This video is sponsored
All right.
by Raid Shadow Legends.
All right. Our answer is going to be a concentration, which is it's fraction. So if we're ending with a fraction, we should start with, all right, we're going to start with a fraction. Now, for this yellow one, 2.4 grams, how do I make that a fraction?
Put it over the liter.
There we go. I'm going to say 2.4 grams of aluminum. And to make it a fraction, I'm going to say, well, I know how much liquid I have. I have 0.250 liters of solution. Great. That's a fraction. Now, let's look at this. I've got liters on the bottom. That's what I want. Beautiful. On the top, I'm starting with grams of aluminum. I want to turn that into moles of aluminum. And then the question doesn't ask what's the concentration of aluminum. It asks what's the concentration of aluminum chloride. So I'm going to change that into moles of aluminum chloride. Okay, that's easy. Where do I look to go from grams to moles? Periodic table. Where do I look to go from moles of one thing to moles of another? Very good. You guys are so good. So let's do this. What should my next line of this be? Moles where? Okay, what's going to go on the bottom? What are we talking about? Aluminum. All right, from the periodic table, we just used aluminum, didn't we? Is it 50-something, 60-something, 63.55? No, that's copper. Aluminum's lighter. What's aluminum?
26.981539.
26.98. Sorry? Can I just put 98? Is that cool? All right, because we only have 2 sig figs, right?
Well, 3, actually. 0.25. Oh, no, 2.
Yeah, 2.4 for the grams. Okay, now if I stopped calculating now, I would know the concentration of aluminum. But the question isn't about the concentration of aluminum, it's about aluminum chloride, so it's my last step. I think I heard what you guys said. We will see if this is in fact what you meant to say. Is that what you meant to say? Awesome. Talk to me. What's this ratio? 2 to 2. And is there anything else I need to do? Because now I've got moles of aluminum chloride on top, and on the bottom I've got liters. All right, that's easy. Nothing wrong with that. Well, really quickly, that's going to be just a little shy of 0.1, and then we're dividing that in 4. So we should be talking less than 0.025, probably 0.021-ish. How much? 255? 253? Okay, I'm sorry, I'm not hearing well today. 355. Oh, I screwed up. That seems high to me. Are we confident in that?
Yep.
Okay, I trust you. And I'll make that 36. And we can say molar of AlCl3. Okay, I like that. Why am I... That seems... Oh, because I'm dividing by 0.25. I'm not multiplying by 0.25. I'm dividing, which means you multiply it by 4, which means that is 9.6. And 9.6 divided by 26. Yeah, that makes good sense. For shame. Okay.
Good sense. Great Shadow Legend does.
Oh, you're good at this. Oh, we got to talk.
I could plug in a sponsorship.
You could totally plug a sponsorship in. This next calculation is brought to you by HelloFresh.
Shamelessly plug in.
Are you tired of eating takeout but don't have time to grocery shop and plan for meals? HelloFresh delivers fresh ingredients to your doorway in a box in pre-portioned ingredients.
Are you too busy because you're playing great?
Okay. Now. All right. So again, we are going to a final concentration, which is a fraction. So we're going to start with a fraction. But here's the beautiful thing. Here's the beautiful thing. This 0.5 molar is already, look here, shh, it's already a fraction.
So why are you putting it in
So what this really means is 0.5 what? Moles in every,
liter?
how many liters? 1. Remember, concentration always means moles per 1 liter. And what are we talking about here? Copper chloride, right? Already a fraction. For this calculation, am I going to need to use that 250 mils?
Yes.
No, because I already have this turned into a concentration.
The one free 5-star hero you can get if you download Rich.
Which means we're actually really close because this bottom is already what I want it to be. So what's the only thing I need to change? I don't want moles of copper chloride. I want moles of aluminum chloride. That's the only change I need to make. I don't know why I wrote that like right over top of it like that, which then makes it impossible for me to do work.
That highlighter.
I can use whatever I like.
Really?
Sure, I have the power.
I have the power to erase it.
So, we're going to go from, so first of all, we've got liters on the bottom, which we like. We've got moles of copper chloride here, which we're going to change to moles of aluminum chloride. And that'll be it. That'll be the question. This, from a concentration to a concentration, is super easy if the volume doesn't change. And here, the volume doesn't change. Super annoying when the volume does change. More on that later. But this one, easy. So, because this liter initial is final, it's all the same. So, I don't want moles of copper chloride. Where should I put it? On the bottom. What do I want? I didn't hear the word you said, but I'm going to assume it was that. And what numbers will make this true?
2.
Okay, does that mean 2 on the top, 3 on the bottom?
Yeah.
Stuff 2 and 3.
All right.
What time do we waste this class talking? Too much.
I don't think we wasted. I
I
think.
don't think we wasted a single second of that.
107 minutes.
And if we look, I like our units. We've got
I
moles.
like that number.
Oh, nice round number. And that works out to 0.33 molar AlCl3. And so if those are the two possibilities, which ones of these actually happens? If I have enough aluminum to make 0.36 molar solution, but enough copper chloride to make 0.33 molar solution, which one will really be the case? Very good. So this is the actual outcome. Which means what runs out? Yeah, very good. The copper chloride solution will be depleted. Oh boy. That can't be spelt right. Can someone do a spell check on that for me? No way?
Depleted or depleted?
Yeah, someone check that for me. That feels so wrong.
Depleted.
That's me when I spelled the cuz on like a day.
Yeah, you no way. No way.
What is it?
No way.
No way.
No way.
That's right. Because that would mean what I put.
No.
This would be. Does everyone? This would be like if you had pants, and those pants had pleats. If you removed the pleats, you would say I depleted my pants, which is not what I meant to say.
I don't even think it's a word. I just think you'd be like, I got rid of my pleats.
That's right. So there we are.
Please stop.
Would be the result. Great job, guys. That is tricky. So we will keep working on that.
Tricky as you saying that word, eh?
I'm doing my best.
Definitely less tricky than downloading Raid Shadow Legends.
You know what's not tricky? Downloading Raid Shadow.
Being able to plug in.
I would say
Shadow Legend.
YouTubers who can effectively pivot to ad copy have a real gift.
I could do
Like
that.
the ones who really do it and you don't even notice they've done it. All of a sudden you're like, ooh, it says promotional sponsored content in the bottom right now.
I could so do that. Oh, that'd be great.
Good job today, guys.
Like my plugins?
Especially your plugins.
You'll get sponsored by Freak Shadow Legend.
Could you imagine if like
You know, I will
I get an
try-
email tonight?
I will try and get rid of sponsorship by
You're like, wow, Orlando, the two people who watched your lesson, they really they both bought HelloFresh. It's kind of crazy.
They both